Hello, my name is Pranav Ned PHYS, and this is my Physics 2212 Lab 2 magnetic field of a bar magnet. The purpose of this lab was to empirically determine the distance dependence of a magnetic field magnitude for a given bar magnet, and then to create a computational model used to predict the on and off axis strength, and then to compare this to the empirically determined values. In order to do this, we assume that no other objects contributed magnetic force at the point of observation other than the bar magnet and the Earth. The system in this case was the magnetometer, and the surroundings were the Earth plus the magnet. The main concept explored was the Biot-Savart law, which relates the strength of a magnetic field to the distance from its distance of observation. We also linearize this in order to determine n, the factor that the r distance is raised to. The results are the n, which is again the power that it's raised to, is negative 2.9468. U, the magnetic dipole moment, was equal to 2.82 Newton meters per Tesla. The x component from the computation model was found to be 9.52 e to the negative 6 teslas, and the x component from observation was found to be e.28 e negative 6 teslas. This is also pretty close. The experimental portion was done in two parts. One was on axis, where the phone was rotated so that the x component of force was 0, meaning that the contribution from the Earth's magnetic field in the x direction was 0, and the magnetometer shift location was found by finding the maximum while shifting phone position, and then the phone was shifted from magnet to various distances so that a standard curve could be generated. The off-axis proportion, we found a distance from where the net magnetic field strength was about 100 microteslas, and then we found the y value of Earth's field in my location, and then the phone was moved up a distance, and d perp. So the y value from Earth's field at my location was just the y value at that previous point, and then the by, the Earth component from earlier, was subtracted from the by measured at this diagonal point, and this was then compared to the computational model. A few quick preliminary observations. The magnetometer did measure a near zero current far from the magnet. It did not measure a smaller current close to the magnet, and the position did affect the x component of the magnetic field. The magnetometer also did measure a larger x component closer to the magnet, meaning that magnetic field strength is closer, the higher the closer you are. This is my data, and as you can see, I measured these values in the yellow, both here and down here, and the graph automatically calculated them, and we got this standard curve. And down here you can see that the x component from the observed magnetic field was 8.28 e negative 6 teslas. Then we were able to calculate u, the magnetic dipole, and n, the power of the radius. And so from the standard curve formula, we were able to determine that the n value is negative 2.9468. So this is the power that r is raised to. The magnetic moment was found using the following formula. So the k constant is equal to 2 permittivity constant times u over 4 pi, and that means that k is equal to e to the negative 14.3829, which is the y-intercept. U is then equal to this formula, and we got 2.82 for this value. So here is my glow script code. So the main important thing is that I created this function over here using the Biot-Savart law to create a vector for the magnetic field, and then later we created these arrows that were proportional that correspond to the different observation locations, blue being perpendicular, orange being on axis, and pink being the 45-degree observation point. And out here, the codes printed out the strength at this 45-degree observation point. So if we had laid out the meter stick at an intermediate angle, Earth's magnetic field would have contributed to both the x and y components, which would make it difficult to determine the contribution of just the magnet or just the Earth's magnetic field, and this would result in an overestimation of the magnetic dipole since we weren't able to eliminate Earth's magnetic field. If we had two identical magnets, there would be no difference in direction, but the dipole moment would become larger, and then the field strength would increase as per the Biot-Savart law. So overall, both the models were pretty close. The computation model was 9.52 e negative 6 teslas, and the x component from observation was 8.28 e negative 6 teslas, which is overall quite close. There was some error, however, and this was probably because this experiment was done inside, so there's a lot of other magnetic fields, such as the lights and other wires that could have affected this. Also, error when I'm holding the phone and I slightly shifted the magnetometer since I didn't really properly do any tape. But overall, the experiment was successful, and a magnetic field was able to be determined with reasonable accuracy, and a model was able to be determined to predict the magnetic field direction and magnitude at any given point.